हेलो एवरीवन, गुड इवनिंग। कैसे हो आप लोग? हाय एवरीवन, कैसे हो? इज माय ऑडियो क्लियर? इज माय ऑडियो क्लियर गाइस? ऑडियो क्लियर है? इज माय ऑडियो एंड वीडियो क्लियर गाइस? कैन यू प्लीज कंफर्म, देन विल स्टार्ट। यस, चलो। यस, आई थिंक इट इज क्लियर. So, guys, a few announcements before we start the session. So, as you all know, these are my free app classes which I have already shared on my Telegram group. So, if you are not following me on Telegram, join the Telegram group so that you will be aware of my upcoming schedule. Okay. So, I have taken till this much and these are still left. So, you can join these classes to practice PSU type questions, ESC, GATE, and other PSU type questions. If you are targeting any PSU, upcoming PSU, then you can join these sessions. So to join these sessions, you have to download the app, and you can download the app by scanning this QR code. Okay. And guys, these are my upcoming schedules for YouTube and app. So already app I have told you, these are all apps with white color, and these are my YouTube classes. Okay, these are YouTube classes. So all these classes are done, but we have shifted this to 15th and this on 17th. So because of some issue, I could not attend these. Okay. So do attend these sessions. This is unsolved PK Nag thermodynamics questions, which is basically the most important questions that you need to solve before your exams. Okay. So join this series. Okay. And today we are on 10th. We are having this session. Okay, just go through this schedule. I have already shared in my Telegram group, and you can if you have not joined the Telegram, please join the Telegram group. And guys, these app sessions are for people who have already covered their syllabus. But if you are still struggling with your syllabus and you are targeting GATE 2024, then you can join this crash course. And if you are targeting GATE 2025 and 26, so very soon we are starting new batches. You can join these batches. All the information is available on the app about all these batches. When are they starting? What will be the sequence of the subjects? When will your subject be completed? How many mock tests? How many quizzes? So everything is already available on app. So you can just download the app, and you can go through the information. If you want to call, you can call on this number and ask for details. Okay. So okay, so all this information is already on the app. How can you download the app? Either you can scan this QR code, or there's a link that is given in below this YouTube video. You can click on this link directly. You will be directed to app, and you can just register yourself and you can access the entire content on the app. Okay. Also guys, for this particular session, you will have a quiz session as well on the app again. Okay. So I'm telling you, there is so much going on the app. If you're on the app, if you are not on the app, you are missing all this. So do not miss. After this session, there will be a quiz that will be uploaded, and that link, quiz link, you will be getting in below this quiz link. You will be getting here at this point, and you can click and you can direct it to the app. Okay, chalo. So guys, as I told you, this schedule and everything is already shared on my Telegram group. If you are not on the Telegram group, then join the Telegram group by scanning this QR code, or you can just search Mechanical by Vipin Yadav and join this Telegram group. Okay. Chalo. Let's start the session. After a quick introduction, we will be solving some of the good questions that were asked in early 90s, I mean 90s and early 2000s. Okay. Chalo. So guys, I have 6+ years of teaching experience and I have taught for GATE, ESC, AE, JEE, all PSUs. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano. I think most of the people know me. And I have 3.5 years of industry and research experience and a few research publications. And my area of expertise is basic and applied thermodynamics and heat transfer. Okay. चलो start किया जाए session. Start किया जाए session. Let's start the session, guys, and let's go with the very first question. Let's go with the very first question. And this is the question. So feel free to answer, and as quickly you will answer, we'll move on to next question. Let me just so an insulated rigid container, just 1 second, guys. Let's start. You just read out the question and we'll start then. Chalo, quickly. Good evening, Anu. How are you? Good evening. Good evening. Quickly answer. So guys, an insulated rigid vessel contains a mixture of fuel and air. The mixture is ignited by a minute spark. The content of the vessel experiences. What are they going to experience? What are they going to experience, guys? So we have a rigid container. So there are two things. First, rigid. If they are saying rigid, that means work will be 0. If they are saying insulated, that means Q will be 0. Yes or no? Yes or no, guys? Now tell me, increase in temperature, pressure and energy, decrease in temperature, pressure and energy, increase in temperature and pressure, but no change in energy, increase in temperature and pressure, but decrease in energy. Good evening, Maniket. कैसे हो भाई? So, as you know, first law of thermodynamics tells me that dq is equals to du plus dw. Now there is no heat transfer, no work transfer. So du will be 0. U initial will be equal to U final. U initial will be equal to U final. अब had it been only air, then temperature must have been constant, but it is not air. It is a mixture of fuel and air. Yes. So therefore, the energy must remain constant. Only the chemical energy will be converted to thermal energy. That is all. But the total energy will remain same. Total energy will remain same, and therefore C is the correct answer. C is the correct answer. ठीक है? Understood? चलो, next question. A vertical cylinder with a freely floating piston. So I have a vertical cylinder. It is freely floating piston, contains 0.1 kg of air at pressure 1.2 bar and a small electrical resistor. What do we have? We have a small electrical resistor. The resistor is wired to an external voltage. Voltage is equals to 12 volt and 1.5 ampere current is passed into the resistor for 90 seconds. How much? 90 seconds. The piston sweeps a volume of 0.01 meter cube. That means your swept volume or change in volume is 0.01 meter cube. Now what do you assume? Piston and cylinder are insulated. That means there is no heat transfer. Q is equals to 0. Air behaves as ideal gas with CV 700 joule per kg Kelvin. So find the rise in temperature. Find the rise in temperature. How do you find rise in temperature? Again, guys, it is a closed system. It is what? A closed system. Now, if it is a closed system, dq is equals to du plus dw. Yes or no? Yes. It is an insulated system. If it is an insulated system, dq will be 0. And therefore 0 is equals to du plus, now what work is happening? One is piston work and one is electrical work. Now electrical work is given to the system. Electrical work is given to the system. So you will take minus here, minus. And this will be mCV T2 minus T1 I need to find out. T2 minus T1 I need to find out dt. Plus piston work is how much? PdV minus electrical work, voltage into current into time. Yes. So I need to find out dt. That means 0 is equals to 0.1 into 700 dt. How much is pressure? 1.2 into 10 to the power 5. Change in volume is 0.01 meter cube. 0.01 meter cube. Electrical work minus voltage is 12, current is 1.5, time is 90 seconds. Tell me how much is dt. Tell me how much is dt. Quickly. dt. Change in temperature is equals to 1. कितना आ रहा है dt? नहीं आ रहा है बाबा. कैसा आएगा 23? कैसे आएगा 23? 6 आ रहा है. 6 कैसे आएगा 23? आ रहा है इतना? आ रहा है इतना? 66 डिग्री सेल्सियस. गाइस, एवरीवन हैज टू पार्टिसिपेट. चलो नेक्स्ट क्वेश्चन. A steam turbine receives steam steadily at 10 bar and enthalpy, यानी कि enthalpy inlet is equals to 3000 kilojoule per kg and comes out at enthalpy of H exit is this. The work output is 250 kilojoule per kg. Now changes in kinetic energy. टेम्परेचर कौन सा टेम्परेचर कह रहे हो? टाइम 90 होगा ना, दिया हुआ है 90 सेकेंड्स दिया हुआ है टाइम, ये दिया हुआ देखो. ठीक है. कूल। चलो, kinetic and potential energy neglected, the heat transfer from the turbine casing, heat transfer from turbine casing. So turbine, we all know it is steady flow energy equation we can apply, and if we apply steady flow energy equation and kinetic and potential energies are neglected, then I can write what? I can write Q in is equals to M HI minus H exit minus HI प्लस वर्क आउटपुट। 10 पुट कितना आएगा? 10 नहीं किया है, वो 90 ही है बाबा, 90 ही है, वो लिखने में ऐसा हो गया 90 ही है। ठीक है, कैलकुलेट किया है मैंने कैलकुलेटर में। ठीक है, चलो, वर्क आउटपुट इज दिस। नाउ दे आर आस्किंग दिस, but they are asking kilojoule per kg, that means it will be small q is equals to He minus Hi plus small w output। ठीक है, चलो, it is 3000 नहीं 2700। प्लस 250 माइनस 300 प्लस 250, कितना आया आंसर? कितना आ रहा है आंसर? -50 किलो जूल पर केजी आ रहा है। इतना आ रहा है? यस। माइनस माइनस लगाना मत भूलो, इट इज हीट ट्रांसफर फ्रॉम द टर्बाइन, हीट ट्रांसफर फ्रॉम द टर्बाइन। ठीक है, तो आंसर क्या हो गया? 50। ठीक है, चलो नेक्स्ट क्वेश्चन। अ स्मॉल स्टीम विसल, विसल मीन्स नोजल, बेसिकली नोजल, ओके, परफेक्टली इंसुलेटेड and doing no shaft work causes a drop of enthalpy. Drop of enthalpy means H2 minus H1. Drop means H2 is decreased, so it will be minus 0.8 kilojoule per kg. So can I say it is H1 minus H2 is equals to 0.8 kilojoule per kg? If the kinetic energy of the steam at entry is negligible, find out exit velocity. So guys, we all know the formula of nozzle velocity at exit. What is nozzle velocity at exit? Is equals to under root 2000 Hi minus H exit. Yes or no? So it is 2000 into 0.8 अंडर रूट, कितना आ गया? यस, 1600 इज इक्वल्स टू 40 मीटर पर सेकेंड। 40 मीटर पर सेकेंड आ गया, एकदम आ गया, बिल्कुल। ठीक है, आगे बढ़े, आगे बढ़े। नेक्स्ट क्वेश्चन। अ कंडेंसर ऑफ अ रेफ्रिजरेशन सिस्टम, सो a refrigerator, I have refrigerator, and this will be condenser, this will be evaporator, this is my cycle taking heat Q2, sorry Q1, Q2, work input. So condenser of a refrigeration system rejects heat at the rate of 120, that means Q1 is equals to 120 kilowatt. While its compressor consumes a power of 30 kilowatt, that means W1 is 30 kilowatt. COP you need to find out. COP is equals to refrigeration effect. Refrigeration effect 1/3. Are you saying COP is less than 1? Refrigeration effect upon work input. Now what is refrigeration effect? Q2, and can I say Q2 is equals to Q1 minus W1 if I do energy balance? Arey Baba, it cannot be less than 1. COP is never less than 1 of VCRS. For VRS, yes, but for VCRS, COP is not less than 1. Okay. Now, how much is this? 90 kilowatt. 90 kilowatt. So, this is 90. This is 30. Therefore, it is 3. COP is 3. Yes or no? कहां से 1/3 1/4 आ रहा है? Yes, it is 3. Chalo, next. Figure below shows a reversible heat engine ER having heat interactions with 3 constant temperature systems. Thermal efficiency, you see, it is a very old question, but these type of question they keep asking. Even recently they have asked this kind of question, okay? Efficiency of any engine is output upon Q in. Now output is this. What is Q in? You see, this is Q in, this is Q in. So output is W. Q in is what? Q1 plus Q2. The problem is I don't know W. The problem is I don't know W. So can I do first law of thermodynamics for a cycle, यानी कि energy balance? Energy in is equals to energy out. What is coming in? Q1 is coming in, Q2 is coming. What is going out? W is going out, Q3 is going out. The problem is I still have 2 unknowns. I still have 2 unknowns. What is the unknowns? Now this is 100 plus 50, 150 kilojoule. So what will I do? I will do second law, dq by t is equals to 0. And I can say, sir, q1 by t1 plus q2 by t2 minus q3 by t3 is equals to 0. Yes. So now I can find out q3. How? By q1 is 100. This is 1000. q2 is 50. This is 500. Then q3 is this. This is 300. Is equals to 0. Calculate q3. How much is q3? q3 is how much? Q3 is how much? Q3 you are going to get 60 kilojoule. So if Q3 is 60, from here work is equals to 150 minus 60 means 90 kilojoule. So now you can write 90 by 150 is equals to how much is it? 6,000. 60%. क्लियर है? क्लियर है क्वेश्चन? Work on your calculations, Baba Maniket. I don't want you at the end of the gate exam you come and say sir calculation mistake हो गया. बहुत दिक्कत हो जाएगा. Next, 1500 watt electric heater is used to heat 20 kg. So electrical work is equals to 1500 watt is used to heat mass of water is equals to 20 kg. Cp is 4186 joule per kg Kelvin in an insulated bucket. Insulated means no heat transfer to surrounding. From a temperature of 30 to 80. So T1 is equals to 303 Kelvin and T2 is equals to how much? 353 Kelvin. If the heater temperature is only infinitely larger than the water temperature during the process, then the change in entropy of the heater, entropy change of heater I need to find out, and entropy change of water I need to find out. So see, water is very easy. I have told you many cases. First case, is it isothermal or non-isothermal? You have to see it is isothermal or non-isothermal. So I can see temperature is changing of water. So it is non-isothermal. ठीक है? Okay. Then you go and see if it is non-isothermal, then is it solid or liquid or gas? Is it, because solid or liquid formula is same, gas formula is same. So as I can see, it is water. If it is water, then you can apply the liquid formula. What is it? Mass Cp ln T2 by T1, T2 by T1, T2 by T1, and you can get 20 into 4186 ln 353 by 303. कितना आएगा ये? कितना आएगा? कितना आएगा ये? 12785 जूल पर केल्विन. जूल पर केल्विन. Now they are saying for heater, and they are saying heater's temperature is infinitely larger. That means when it is 30, then heater temperature is 31. When water is at 31, heater temperature is 32. When it is 80, heater temperature is 81. That means heater also is increasing with the same amount. Heater temperature is also increasing with the same amount. So it will basically be negative. That means its entropy will be negative of this. It has a negative effect. Okay. It is giving heat. Water is absorbing heat. So it will be minus of this. And therefore, you can write both of them. Entropy of heater, entropy of water is this. If the entropy of universe, it's 0. Because it is a reversible process. When the temperature difference between two bodies is infinitely smaller, then reversible heat transfer takes place. Reversible. Okay. So for universe, it's 0. In this process, if you ask how much entropy is changing in this process, it is 0. Okay. Chalo. Next. For two cycle coupled in series, topping cycle efficiency. A very easy formula. You see, recently also they have asked this question. Bottom is equals to 0.2. Overall, I need to find out overall. Overall, I need to find out. What is the formula? Guys, look, we can make two cycles and we can prove this as well. But in our classes, we have proved this. What is this? N1 plus N2 minus N1 into N2. 0.3 plus 0.2 minus 0.3 into 0.2. कितना आ रहा है ये? 0.5 minus 0.06. So 0.44 and 44% is the overall efficiency. आ रहा है या नहीं? आ रहा है या नहीं? Still they are asking these kind of questions. You see, it's a very old question, but still I think it is 1990 something, very old, 1994 or something. Yes, chalo, next question. Now tell me quickly, what is this expression telling you? T ds by dt at constant pressure minus T ds by dt at constant volume. What is it equal to? What is this equal to? So if you remember, if you draw a TS diagram, so what is the slope of TS diagram? By dt by ds, dy by dx, isn't it? And if I use constant pressure, that means it is the slope of constant pressure line. It is the slope of constant pressure line. So it is T by Cp. Also, dt by ds at constant volume slope is how much? T by Cv. So let me substitute Cp by T minus T into Cv by T is equals to what? T cancel, T cancel. Cp minus Cv is equals to what? R. A is correct, not B. A is correct. Clear? Clear? Chalo. Common data question. Nitrogen gas with molecular weight 28 is enclosed in a cylinder by a piston at the initial condition of, so P1 is 2 into 10 to the power 5 Pascal. T1 is equals to 298 Kelvin and V1 is equals to 1 meter cube. In a particular process, the gas slowly expands under isothermal condition. The process is isothermal. That means T1 is equals to T2 and V2 is 2 times 2 meter cube. Heat exchange occurs with the atmosphere at 298 Kelvin during this process. So there is some heat transfer happening. Calculate the work interaction for nitrogen gas. Work interaction. So we all know work transfer in isothermal process is P1 V1 ln V2 by V1. Yes or no? P1 V1 and V2 by. Now I know P1, guys. I know 2 into 10 to the power 5. V1 is 1 ln 2 by 1. कितना आएगा ये? कितना आएगा? कितना है ये? 2 into 10 to the power 5 into ln 2. 138.629. I'm getting in joule is 629.4 joule. But in kilojoule it is 138. 138. Okay. Then what is the next part? Entropy change for universe. Entropy change for universe. Entropy change. So entropy change of universe is equals to entropy change of system, means nitrogen gas, plus entropy change of surrounding. Entropy change of surrounding. Now tell me, guys. Of course, surrounding temperature is not changing. Surrounding temperature is not changing. But system, nitrogen, temperature is changing. No, temperature is not changing. So what will I use? What will I use? Whenever there is gas, I need to use this formula. Gas can be calculated, entropy for gas can be calculated two ways. Entropy of gas can be calculated two ways. यस और नो? क्या है जीरो? कहां से आ गया जीरो? कैलकुलेट किया है ऐसी? देखो भाई, टू फॉर्मूलाज आर देयर, व्हाट? सी पी एल एन एम सी पी एल एन T2/T1 प्लस एम आर एल एन V2 बाई V1, या फिर सॉरी एम सी वी इट इज MCP ln T2/T1 माइनस MR ln P2/P1. So we can use any of them. We can use any of them. But we know one thing, that temperature is constant. Temperature is constant. So if temperature is constant and volume is given to me, both the volumes, so I will reduce the temperature and I can write MR ln V2/V1 plus. Now in surrounding, heat transfer is happening to surrounding, yes, but surrounding temperature is not changing, so Q upon T of surrounding. Okay. Now what is mass, sir? What is mass? Mass I need to calculate by mass is equals to P1 V1 RT1. P1 V1 RT1. Okay. So let me write P1 V1 RT1 into R ln V2/V1 plus Q. Q is what? How much heat you are adding? How much heat you are adding? How much heat you are adding? How much heat? What is this process? What is this process, Baba? Isothermal. Isothermal is dq is equals to du plus dw. Isothermal, du is 0, that means dq is equals to dw. Same heat, whatever work you are getting, same amount of heat you are adding. So it is work upon T of surrounding. T of surrounding. Now this R and R you can cancel. P1 is 2 into 10 to the power 2 into V1 is 1. T1 is 298 ln2 plus 138.6. Temperature of surrounding is what? 298. So now you can calculate entropy change of universe, and yes, you are going to get 0 because they both will remain same. They both will be same. They both will be same and it will be cancelled. It will be cancelled and entropy of universe you will get 0. One will be negative. Look, this will be negative. One will be negative, one will be positive. Okay, so this is minus of work, right? It is what? Minus. Okay. So it will be 0. So this will be negative, this will be positive, and it will be 0. If you calculate, you can do that. ठीक है, चलो नेक्स्ट क्वेश्चन देखते हैं. A heat reservoir at 900 Kelvin is brought into contact with the ambient at 300 Kelvin for a short time. During this process, 9000 kilojoule of heat is lost by the heat reservoir. I have a heat reservoir of 900 Kelvin and I bring it in contact with a 300 Kelvin ambient. Ambient means temperature of ambient is not going to change. And how much heat is transferred? 9000 kilojoule. the total loss in availability. Bhaiya, what is loss in availability? Work lost is what? Irreversibility is what? T naught into entropy change of universe. Entropy change of universe. So I can also write, bhaiya, T naught is equals to entropy change of system, which is my reservoir, plus entropy change of ambient. Yes. Now, this is basically, this is Q lost minus Q. It is losing heat. Reservoir is losing heat by temperature of reservoir, plus environmental is ambient is absorbing heat, Q upon T naught, Q upon T naught. Yes, yes or no? Now you can do T naught into minus, okay, this color is not good, minus Q by T reservoir plus Q. So this is minus T naught is what? 300 into 9000. This is 900 plus 9000. Quickly calculate how much is this? How much is this? 6000. Very good, 6000. If you can only refer to the tables that I have given you in class, it is more than enough, guys. Your 90%. First of all, you need to find out what to calculate in the question. And then if you found out what to calculate, go for the cases that I have given you in class. Simple. Just try to simplify the problems in terms of cases. Break the question in terms of cases. ठीक है, ठीक है, चलो. 6000 is the correct answer. Now, a steel billet of 2000 kg mass. I have mass of 2000 kg of steel is to be cooled from, so initial temperature is 1250 Kelvin, final is 450 Kelvin. I am cooling it. Heat released during this process is to be used as a source of energy. The ambient temperature is 303 Kelvin. T naught is equals to 303 Kelvin. The specific heat of the steel is Cp. C of steel is 0.5 kilojoule per kg Kelvin. Available energy I need to find out. Again, go for the cases. We have done two cases. First, find out available energy for infinite heat source. That means thermal energy reservoir when temperature is not changing. Then the second case is find out availability or available energy for a finite heat source. One is infinite, one is finite. So what is this? Here temperature is changing, so it is finite heat source. And what is the formula, guys? T naught entropy change of universe. Same as irreversibility. We have proved this. Irreversibility and this has the same formula. Okay. Now, it is system plus surrounding. System is steel ball, steel billet. Okay. Now, system is non-isothermal solid. Solid, what is the formula? McLn T2 by T1. Surrounding. Surrounding is absorbing heat. Absorbing heat. Q upon T surrounding. So T naught mass is 2000 into 0.5 into ln. T2 is final is 450. Initial is 1250. I think I'm going to hide it behind me. So let me erase this. And let me write here. T naught mass is 2000. C is 0.5. ln. T2 is final temperature 450. It is initial temperature plus. Now what is the heat transferred to surrounding? How much heat is getting transferred to surrounding? By the heat that is lost by steel billet. Yes. So how much heat is lost by steel billet? mc dt by T naught. So I can write this as 303 into 2000 into 0.5 ln. Calculate quickly, guys. Calculate quickly. Plus now T naught will get cancelled. Mass is 2000 into 0.5 into 1250 minus 450. कितना आ रहा है? कितना आएगा? Calculate. सी कैसे आ रहा है भैया? सी कैसे आएगा? सी कैसे आएगा? Should I calculate it? 303 into 2000 into 0.5 into ln 450 divided by 1250 minus 309,560.3 plus 800000 करो जल्दी minus 3095 this is 490,439.7 kilojoule. So if you convert it into megajoule, you will get this. Got it? Yes, D is correct. Chalo, next question. Second last question for today. The following table of properties were printed out from a saturated liquid and saturated vapor of ammonia. The titles for only the first two columns are available. All that we know is that the other columns 3 to 8, yani ki this is 3, 4, 5, 6, 7, 8. Contains data on specific properties, namely internal energy, enthalpy and entropy. Now they are asking calculate the specific enthalpy data. Tell in which table we have specific enthalpy data. Now before you go ahead, I need to remember one thing. H is equals to U plus PV. That means H will be greater than U. And U will be greater than S. That means S will be the smallest, U will be the middle, H will be the highest. And if you can just closely watch the figures, if you can closely watch, and U will be very close to, U will be very close to H. U will be very close to H as well. Okay. Now, so as you can see, the highest enthalpy, I have to find out the highest values. I have to find out the highest columns, values with the highest column. Can you tell me? So as you can see, this is 88.78. If you add something to it, it will be 89. And this is your enthalpy of fluid. And now 1299 plus you add a little bit, it will be 1418. So this is your Hg. So these are your enthalpy columns. They are your enthalpy columns. And these are your entropy columns. And these are your internal energy columns. SF, UF, UG. UF, UG. Okay. So it is 5 and 8. 5 and 8. Okay. Now, next they are asking, when saturated liquid at 40 degrees Celsius is throttled, the quality of exit, that means if I have a TS diagram and I am throttling like this, 1 to 2. Now this is my 40 degrees Celsius. Throttling you will do for liquid only, right? Minus 20 degrees Celsius. So I need to find out quality, this quality, which is X2. खत्म कर लो, लास्ट क्वेश्चन है, ठीक है. नाउ टेल मी, दिस इज थ्रोटलिंग प्रोसेस. थ्रोटलिंग means H1 is equals to H2. And what is H1? What is H1? H1, first of all, I have to see where is my point 1. It is at 40 degrees Celsius. First, ठीक है. Point 1, 40 degree. Then, on 40 degree, where? Where on 40 degree? On saturated liquid. So, 40 degree, where, Baba? Where? Saturated liquid means HF. HF. So this is 371.43. Now H2 will be HF plus X, Hg minus HF. Now whenever I find anything from point 2, I have to see where is point 2, at minus 20. So whatever value I need to find out, I will find out from minus 20 degree. Minus 20 degree. So I need to find out HF and Hg from minus 20. So bhaiya, this is my minus 20. This is my HF. This is my Hg. This is my Hg. So 89.05 plus X, 14, 18 minus 89.05, 371.43. So now you can find out your X. How much is X? Very high. Should be very high, na? So, sorry, very low. It is near to the liquid curve, so it should be very low. It should be very low, because it is near the liquid curve. If it is near the vapor curve, it should be very high. Yes, yes, I think it is correct. Just calculate. If you have calculated correctly, it should be correct. ठीक है? So I think this is correct only. 0.212. ठीक है? चलो, very good guys. We have solved around 15 questions today. We have solved around 15 questions. And this series is still going on. So do not forget to attend the rest of the sessions, guys. And also, we have 11th and 12th. We have scholarship test. So do not forget to attend the scholarship test if you want to. Enroll for the paid courses, okay, and only the financial restrictions are there for 2025, 26, whatever course you want, just sit for the scholarship test, okay. Chalo. And guys, also mock test is going on, so these are part test, these are full test, and if you are targeting GATE 2024, then you must enroll. wherever you want to enroll and must give mock test. Very important guys. ठीक है, चलो let's stop here guys, let's stop here, and I will see you very soon. As you all know my schedule already, I will see you on 15th. On 15th we will solve PK questions, unsolved questions at 9 p.m. Okay, chalo, let's stop here guys. Thank you so much. Thank you Anu. Bye bye.